In this video, we're going to go over geometric series and we're going to derive the formula for solving them. So a sequence is a set of numbers, the series is the sum of the numbers, and a geometric one has a common ratio. So we multiply by something. So if we have the general term for this, we know that Tn equals T1 times Rn minus 1. So that's the general term. So if we wanted something over here, let's say T1, that's just T1. And then T2, that's T1 times R. T3 is T1 times R squared. Okay? So there's this ratio that's common. So now if we want the sum of them is just going to be, well, that's T1 plus T2, but T2 is T1 times R plus T3, which is T1 R squared, plus, and we keep going, and then we get something like very close to the end, we have T1 times R n minus 2 plus T1 R n minus 1, and that's our nth term. So now let's say we had another sequence, but I'm going to multiply this one by R. So that's going to be R T1, so that's my first term, and then I'm going to have R T R squared T1. I've kind of written this backwards, but I'm going to shimmy it over. And then I have T1 R cubed. And then I get to here, and I have T1 R n minus 1 plus T1 R to the power of n. So you can see that this term and this term are the same, this term and this term are the same. I've put the R in front of it. And then this term would have a missing term here. It's just in the dots. And then this term aligns with this term, as this one aligns with something in the dots as well. But now I have this and this that don't have pairs. Well, what if I just do this? This is quite straightforward. What if I just said, well, I have Sn, let's say R Sn minus Sn. Okay, well, if I took this and I subtracted this, well, I'd find that this term and this term cancel out, this and this cancel out, this and this cancel out, this and this cancel out. This one's going to cancel with something in here, as this one cancels with something in there. So then what I'm left with is I have this, which is T1 R to the power of n minus T1. And then I have that. So what I'm going to do is I'm going to say I can factor my Sn out. So I have R minus 1 times Sn, and that's equal to T1 Rn minus T1. And then I solve for Sn, and I have T1 R to the power of n minus T1 all over R minus 1. So now we've made a formula for this. So we can kind of look at this, well, we can look at this, and we can see that this term is actually the same as T1 times R to the n minus 1 times R minus T1. And that's R minus 1. But this is just Tn. So I can write this as Tn times R minus T1 all over R minus 1. So we have two possible formulas here now. We have Sn equals, and we can factor that out. We can have T1 times Rn minus 1 over R minus 1. Or we can have Sn is equal to Tn times R minus T1 over R minus 1. So it depends what variables we have or what unknowns and what knowns we know for these to find the series or the sum very quickly. And we'll do that in another video where we go over some examples.